Why does AI need so much electricity?
Last time, we explored data centers and how AI is actually supported by massive physical infrastructure behind the scenes.
Yeah, GPUs, electricity, cooling, networking. AI felt way more industrial than I expected.
This time, we're going one step further. Why does AI consume so much electricity and water?
Honestly, seeing companies like Microsoft and Meta securing nuclear power lately completely changed how I think about AI.
The first thing to understand is that generative AI isn't lightweight software. It's massive computation running on enormous GPU clusters.
So every time ChatGPT answers a question, there's actually a huge amount of processing happening behind the scenes.
Exactly. Things like next token prediction, contextual understanding, probability calculations, and attention computation are all happening simultaneously across large numbers of GPUs. And now AI is expanding into images, audio, video, and long context reasoning, which keeps increasing computational demand.
And millions of people are using these systems at the same time. At that point, it feels less like an app and more like a permanently operating industrial facility.
That's actually pretty close to reality. And recently, inference demand has exploded. In the past, the main focus was training models once. Now we've entered a world where AI is being used constantly, every day, by people worldwide.
So now the challenge isn't only can we build smarter AI, but also can we continuously power that AI?
Exactly. That's becoming one of the central issues of the AI era. And AI GPUs themselves are becoming extremely power hungry. For example, NVIDIA's H100 can reach roughly the 700 watt range depending on configuration.
700 watts for a single GPU? That's already huge.
And then, data centers deploy thousands, sometimes tens of thousands of them together. Modern AI systems are starting to treat entire racks as single giant computing units.
At that point, server rack sounds way too small of a word for what these things actually are.
Pretty much. That's why companies are now redesigning infrastructure itself. Liquid cooling, high-density power delivery, dedicated substations, and even power generation strategies.
And that connects directly to all those nuclear energy headlines lately.
Exactly. Microsoft has pursued long-term nuclear-related power agreements connected to AI data center expansion. Meta has also moved toward long-duration energy agreements tied to future AI infrastructure growth.
So AI companies are slowly turning into energy companies too.
That's actually one of the biggest structural changes happening right now. The competition is no longer only who has the smartest AI. It's also who can secure stable electricity for the next decade.
So underneath the AI intelligence race, there's also a massive energy race happening at the same time.
Exactly. And that's one of the key realities behind modern AI.
Why does AI need so much water?
AI doesn't just consume huge amounts of electricity. Managing all the heat it generates is becoming one of the industry's biggest challenges.
So, now we're moving from a computation problem to a heat problem.
Exactly. And that's where the massive water consumption comes in.
Honestly, I never associated AI with water before this.
GPUs generate enormous amounts of heat when they process AI workloads. And modern AI systems are becoming more powerful, more densely packed, and more interconnected, which dramatically increases thermal density.
So the problem isn't just how much power they consume, but also how much heat gets trapped in one place.
Exactly. Some modern AI racks now consume power comparable to multiple homes combined. And next-generation systems like NVIDIA's Blackwell architecture are expected to push rack density even further.
So, as AI gets smarter, cooling becomes harder too.
Very much so. Traditional data centers relied mostly on air cooling. But now, many companies are approaching the practical limits of what air cooling alone can handle. That's why liquid cooling is spreading so quickly now.
So instead of just blowing air through servers, they're directly using liquids to absorb heat?
Exactly. Technologies like direct liquid cooling, cold plates, and immersion cooling are becoming increasingly important.
Honestly, this is starting to sound more like industrial engineering than computing.
That's actually a very accurate observation. Especially with newer high-density AI systems, cooling infrastructure itself is becoming part of the core design. You can't simply add more GPUs anymore. You also have to design how to remove enormous amounts of heat safely and efficiently.
So, AI infrastructure is now constrained by thermodynamics too.
Exactly. And many cooling systems use evaporation to release heat, which requires very large amounts of water.
That explains why people are suddenly talking about AI and water shortages together.
Right. Google's environmental reports have already acknowledged that rising AI-related data center demand is increasing pressure on both electricity and water usage. Microsoft has also reported growing water consumption associated with AI infrastructure expansion.
So AI isn't just software running in the cloud. It's deeply connected to energy systems, water infrastructure, and physical industrial equipment.
That's one of the most important things people are starting to realize. Modern AI now sits at the intersection of semiconductors, energy systems, cooling technology, and water infrastructure, all at the same time.
The deeper we go into AI, the more it feels like we're looking at the operating system of an entirely new industrial civilization. AI is entering the era of infrastructure constraints.
At this point, AI is starting to look less like a software industry and more like a battle over infrastructure itself.
Yeah. We started with semiconductors and somehow ended up talking about power grids, water systems, and national infrastructure.
And recently, people have started saying that AI performance itself may eventually be limited by infrastructure capacity.
So eventually the bottleneck might not be can we build smarter AI, but can society physically support it?
Modern AI systems are moving toward long context reasoning, video generation, multimodal AI, and autonomous AI agents, which all require continuous computation.
So the challenge is no longer just training AI once. Now, it's about continuously running AI at global scale.
Exactly. And according to the IEA, global data center electricity demand surged sharply again in 2025, driven heavily by AI expansion. Some forecasts even suggest that data center electricity consumption could roughly double by 2030.
That's not normal industry growth anymore. That's infrastructure scale growth.
Exactly. AI isn't just changing software anymore. It's starting to reshape energy demand itself. That's why major tech companies are increasingly behaving like infrastructure companies.
Yeah. AI news now constantly overlaps with energy policy and utility discussions.
For example, Amazon has been redesigning AI-focused data center infrastructure with liquid cooling, higher rack density, and AI-optimized power systems. That is because traditional cloud infrastructure is no longer sufficient.
So, AI hardware is evolving faster than the old data center model can handle.
Exactly. And another major issue is location. AI data centers increasingly need to be built where electricity, cooling capacity, land, and grid access are available simultaneously.
So, geography matters again.
Very much so. In some regions, power grid constraints are already slowing down future AI data center expansion plans.
That completely changes how I think about AI. It's not just a technology race, it's an energy and infrastructure race too.
Exactly. Modern AI now depends on semiconductors, power generation, cooling systems, water infrastructure, and electrical grids all working together at once.
Honestly, it feels like we're watching the construction of a new industrial civilization in real time.
That's actually a pretty accurate way to describe it.
Summary. When you realize how much electricity, water, and infrastructure are moving behind ChatGPT, AI starts looking completely different.
It really does. Modern AI can no longer be understood as just software.
Semiconductors, power grids, cooling systems, water usage, everything is becoming interconnected.
Today, we explored why AI consumes such enormous amounts of electricity and water.
At first, I thought AI probably uses a lot of power, but by the end, this felt more like a discussion about civilization infrastructure itself.
Because modern AI depends on enormous systems working together: GPUs, electricity, cooling, water, and networking, all simultaneously.
And now, the competition isn't only who builds the smartest AI, it's also who can secure enough infrastructure to support that AI.
Exactly. That's why we're seeing nuclear power discussions, renewable energy investment, AI-focused power infrastructure, and liquid cooling expansion becoming deeply connected to AI development.
So, the AI revolution isn't only transforming software, it's transforming energy systems, industrial infrastructure, and maybe even the structure of society itself.
That's one of the most important ways to understand what's happening right now.
Honestly, after learning all this, opening ChatGPT feels completely different now.
I think a lot of people are starting to feel that too.
Thanks for watching today's video. See you next time.